Ladies and gentlemen, welcome to a sixth video lecture on the Fivefold Sun after the book that was filed at the Bibliothèque Nationale de France in Paris in late 2017. We are now about a year later on October 6th of the year 2018. Video 6 focuses on the interpretation of the results found in part 1 of the Fivefold Sun project in terms of a solar dynamo through the quasi-decadal solar cycle. The conclusion that can be drawn from the results so far found in part 1 of the Fivefold Sun are that there are certain numbers of rigid rotations that are performed over the entire Schwabe cycle, the quasi-decadal solar cycle, that in fact translate into very different numbers of rotations because of differential rotation at the solar equator and at the solar poles. There is a difference, in fact, of exactly 60 rotations, which we will call now laps, in the solar ball between the number of equatorial rotations and the number of polar rotations, at least for the central estimates that we were able to suggest based on the meta-analysis of results published in solar physics literature in the current project. In video 6, we first start with mentioning and discussing the difference of 60 laps that I just mentioned. And now we will begin to propose an interpretation of these laps in terms of a winding of global magnetic lines of force in the Sun along the lines of the very famous fundamental Babcock model of the solar dynamo that was proposed by the late Horace Babcock in 1961 and remains to this day the main contender, the main candidate for a solar dynamo process that is verified in observations. Then we will turn back to the numbers of rigid rotations in the solar ball and mention a very remarkable property of the number of rigid rotations, which is found to be the central value for the length of the entire solar quasi-decadal cycle. 143 is the only square Fibonacci number and one of two powers in the entire infinite sequence of Fibonacci numbers apart from 1. And finally, we will briefly mention the possibility that a 144 rotation solar cycle length, a stellar cycle length, might be present as a central value for the parameters of the cycle and rotation of the heretofore known solar analogues. The difference of 60 laps is found in the number of rotations performed at the solar equator versus the number of rotations performed by the solar ball at the solar poles within the uncertainties that we mentioned in the previous video number 5. As you can see in this table, if you look at the rise leg, its central value for the number of polar rotations compared to the central value for the number of equatorial rotations will be depending on will be in the range of 22 to 24 with a central value of 23 rotations. For the fall leg, the central value will be 37 rotations. And you see that for the overall Schwabe cycle, the number of rotations that is expressed by this difference adds up to 60. We now propose to interpret this 60 equator to pole number of laps, which is observed according to our calculations in each hemisphere of the Sun, i.e. 60 laps in the northern hemisphere. They appear simultaneously with 60 laps in the southern hemisphere over a Schwabe cycle. These laps, they yield 60 terms of the global magnetic lines of force during the solar cycle in each hemisphere, and we will then venture to suggest that these 60 turns will yield exactly 60 bipoles in each hemisphere at solar maximum epoch. The identity of the number, the characteristic number in the winding process and the number of bipoles is already introduced in Babcock 1961. So, in fact, we are not innovating a lot in this matter when we suggest this winding process in each hemisphere. We are just extending the Babcock winding model of 1961, which was restricted to latitudes lower than 55 degrees latitude. In our case, we contemplate the entire span of latitudes from equator to pole. So we start with the 60 lap accumulation process in the case of the presence of global magnetic field lines. We consider the classical Babcock field line turn model and see why it, in our view, should be expanded up to the Sun's poles. We explain how the 60 field line turns may amplify a magnetic field which might, in fact, emerge at the very depth in the solar ball, very near the surface, which is suggested by recent observations and investigations of helioseismologists. And we will finish with the postulate that for 60 laps we will have generated over a cycle exactly 60 sunspot bipoles. Note that beyond this pure conjecture of an identity of the number of laps in each line of force and the number of bipoles at sunspot maximum, in part 6 we will see through another meta-analysis of the databases in leading observatories of the Sun that there is a characteristic number of observed bipoles which is 60 or at least is very close to 60 indeed. The classical Babcock field line turn model is expressed in Horace Babcock's 1961 famous paper, The Topology of the Sun's Magnetic Field and the 22-Year Cycle. Of course, the 22-year cycle is 2 Schwabe cycles of 11 years. It is a Hale full magnetic cycle. And we can summarize Babcock's original thesis as formulated in 1961. In this way, differential rotation winds up global magnetic lines of force in the Sun from 55-degree latitude in the higher latitudes to the equatorial region. The resulting turns, as Babcock called them, in the lines of force result in the eruption of magnetic dipoles at the solar surface from some depth in the solar ball. And schematically, one dipole emerges in each twisted line of force. This is sketched in a famous cartoon in Horace Babcock's paper. There have been many followers of Babcock. There have also been many attempts at completely different concepts for the solar dynamo. So far, none of the former and none of the later attempts have squared up with observations. So we come up in 2010 in part 1, published only in 2017 as part of the entire Fivefold Sun project comprising 6 parts. That this model is basically verified by observations, the 1961 model. The winding of global lines of force is a relevant solar dynamo model, but you have to wind up the global magnetic lines of force in the Sun from pole to equator, not only from 55-degree latitude. The resulting turns, which we now call laps, in the lines of force will result, as Babcock proposed, in the eruption of magnetic dipoles. And schematically, in our case, there will be one dipole per lap in a line of force. As I just mentioned with the previous page, in part 6 we shall see that the actual numbers of sunspots amount to, in effect, 60 dipoles per hemisphere as a characteristic value in each hemisphere of the Sun at sunspot maximum epoch. Of course, the postulate that if there is winding of lines of force by differential rotation, that this should be contemplated from pole to equator over 90 degrees. This is the most controversial part of the proposal, the suggestion that is put forth in this page and in this video number 6, and which is the final tenet of in part 1 of the Fivefold Sun. First piece of evidence tending to demonstrate that we have to look at the entire 90-degree span from equator to pole and not restrict ourselves to only 55 degrees of a winding span, is that in filament geometry at the surface of the Sun, we can see these giant filaments that extend across almost the entire hemispheric solar surface. And these filaments, they seem to span the entire 90 degrees of the northern hemisphere and 90 degrees of the southern hemisphere. Another piece of evidence that there are global lines of force extending from pole to pole through the equator, and that can be driven like a bow by the faster rotation of the equator, is the presence of the polar plumes. The polar plumes are very interesting to consider in this matter. They are these hairs that seem to be extending from the polar cap outward radially into outer space at each pole of the Sun, that can be seen, especially in regular light during each total solar eclipse, and were in fact discovered in the late 19th century during total solar eclipses. And we have evidence, despite a long-lasting controversy about this issue, that they are evident up to at least 87 latitude, i.e. within less than 3% of the poles. These plumes were interpreted by Bigelow, the American physicist, around 1890 for the first time as evidence of the presence of lines of force in the solar ball. This was the very finding, the very observation that brought up the notion that the sun might be a magnet, that the sun and its magnetic field might be represented during solar eclipses by the geometry of the plumes. So if we can see the plumes in a ring so close to the solar poles, evidently they are not, as was previously assumed, ending slightly above the somewhat theoretical boundary of the unipolar solar field about 55-degree latitude. They would not be ending either around 70 or 75-degree latitude, as many authors in the mid 20th century supposed. So if we agree that we can postulate 60 field line turns across the entire latitudinal span of the solar ball, where are these lines located in depth? This is another major controversy of solar physics and about the solar dynamo. Whether the solar dynamo is located in the interior of the convective zone, perhaps near the border with the radiative zone, or if it is located in a subsurface, near-surface zone, or whatever. When I was invited to the Space Climate Conference in Oulu in Finland in 2013, I had the opportunity to ask Paul Charbonneau, who is maybe the leader of present-day research in the theory of solar dynamo. Paul, where is located the solar dynamo? And Paul Charbonneau said, we don't know. So if the boss doesn't know, who knows? And maybe these guys have a hint at where it is located. This is a publication in 2009 by Boldner et al., where they suggest from helioseismologic measurements that the predominant magnetic field in the sun is toroidal and is located at this depth. So this depth is, coincides with the depth at which the suggested 60 laps are performed in the thesis proposed in our Fivefold Sun project, because as we saw in the previous video number 5, this is where the slowest rotation takes place in the polar region, and this is also where the fastest rotation takes place in the equatorial region, although similar rotation takes place also at least 1 or 2 depth further inside the solar ball near the equator. So this would be mounting evidence that we are on the right track and that if we have a global winding process for magnetic fields, magnetic lines of force in the solar ball, this is happening at the depth that we find to be consistent with the suggested process. Now, the 60 laps do not accumulate over a Hale cycle. In the first Schwabe cycle of the Hale cycle, 60 laps accumulate in the North Hemisphere. Again, 60 laps will accumulate in the North Hemisphere in the second Schwabe cycle, ending a Hale cycle, but they do not add up. They remain adding up to a maximum of 60 laps. We now turn to another, turn back to the consideration of rigid rotation in the solar ball. We found that the total number of rigid rotations in the solar ball over the Schwabe cycle, the quasi-decadal cycle of canonically 11 years and 10.6 years for its median central value, characteristic tendency of the length of the Schwabe cycle, which corresponds to 144 rigid rotations. Well, 144 we found is a Fibonacci number. It's the 12th Fibonacci number. It is also the square of 12. You see, we have a major property here that it is a square because it is the only perfect square in the entire infinite sequence of Fibonacci numbers, apart from 1. Note that it is also the 12th Fibonacci number, and it is the square of 12. So this seems to be a very special Fibonacci number. We will make note also that there is only one other perfect power in the infinite sequence of Fibonacci numbers. It is the number 8, which is a cube. These assertions, these asserted properties that I just mentioned, they were proved. The proof was published by Bugeaud and his collaborators in 2008 for 144 being the only square, and in 2006 for the cube. So maybe we have here a clue that the Fibonacci sequence representing a fivefold symmetry in a numerical way, because the consecutive integers in the sequence are related by the ratio 1.618, mean and extreme ratio, which is specific to the fivefold solids, the icosahedron and the dodecahedron. Maybe we have a clue that fivefold symmetry is present in the numerical kinematic of the Sun, and maybe a hint that it might be present in the space structure of the solar ball as a solid body. Finally, I will briefly mention that the 444 rotation cycle length maybe is present in other solar analogues, and maybe there is some evidence that it might be the central value number for solar analogues. We have only a very small data set of about 50 such stars as of 2017, when this table was put together as one of the last findings in this project before it was filed at the Bibliothèque Nationale de France a year ago. You see here 3 different samples of solar analogues that were published in 2007, 2009 and 2017. There are also data from 2 other publications. All in all, there are only, again, about 50 different stars. Some of the various authors use the same stars. We cannot add up the number of stars in each data sample. The bottom line is that the mean number of rotations for the entire set of solar analogues under review is 148 in this sample, 144 in this sample, 153 in this sample. For the entire set, the mean of the means is 142. Based on the mean number of rotations, we find about the same result as we found for the Sun itself. Now, for the median, we have much lower numbers and an average of 129 for the entire set of all samples, 129 rotations. So the question is open. We do not know. We need a larger set of solar analogues and better resolved observations to confirm this potential finding. We are now finished with part 1 of the Fivefold Sun, and we will now turn to the 3D structure of the solar ball in part 2 of this project. Thank you for your attention.